a satellite system engineer at Turksat for about 16 years. I worked in different positions, but right now I'm the program coordinator of Turksat 6A, which is a domestic satellite program. Today I'm trying to tell you about our satellite fleet and our infrastructure, and after that the latest satellite programs we have, Turksat 6A and Turksat 5A and 5B, and the Turksat 6A, and what outcomes we have from these projects, and what are we thinking about future. So I will try to give you a bit insight about that. A little bit of introduction of Turksat. Turksat is the only geo communication satellite operator of Turkey. We are providing services for data, voice, all kind of geo satellite communication services. We try to provide whatever our customer needs from satellite, and basically the internet and the broadcast is the main business of our satellite. And the other one is the cable TV operations, one of the main business Turksat have. Up to now, since 1994, we launched 8 communication satellites. The first one, 1A, was exploded with the rocket. And after that, the same type of satellite, Turksat 5B, was launched. And after that, we had, as I said, total 8 satellites. At the moment, 3A, 4A, 4B, 5A, and 5B are live in orbit operating. And Turksat 6A the manufacturing has been completed and it's under test for a while. I hope within next year, at the beginning of next year, it will be launched. That was our satellite fleet, and the next one is the latest satellite programs we had at Turksat. At 2017, we signed a contract with Airbus after a long process of bidding, and the contract was for 2 satellites, and the project consisted of delivery of the 2 satellites. One of them is Turksat 5A and the other one is 5B, 35 and 42-degree east orbital slots. The contract consists of launch service plus insurance as well, and also ground control systems, operator trainings, technology transfer programs, and local industry participations. That's a huge project for us, and I feel I'm lucky that I was involved in this project as payload specialist from the scratch to the in-orbit delivery of the satellites. And it took around, as you see, we launched 5B at the end of 2021, so it took around 5 years for us. And yeah, Turksat 5A and 5B satellites are the first one for us that have electrical propulsion. It was a new experience for us. And thanks to these propulsion systems, we had more than 30 years of maneuver lifetimes. As I said, the contractor was Airbus Defence and Space Systems. The platform was E3000 electrical propulsion. We launched 5A in January 2021 from Kennedy Space Center, Cape Canaveral, actually, sorry. And it's being operated at 31 east orbital slots, and it's around 3.5 tons of launch mass. It's a powerful satellite which has more than 12 kilowatts of power, and the payload it has is Ku band, and we call new Ku band, and in some regions they call KUBSS. Maybe some of you are not familiar with this new Ku band. It's around, the uplink side is around 14.5 to 14.75 gigahertz, and the downlink is 13.4 to 13.65 in downlink side. And 5P, it's much more powerful than 5A, and it's the most powerful satellite we have in our fleet. And we have big expectations on this satellite. Again, the contractor was Airbus Defense and Space Systems, and the platform was the same. It has been launched around 11 months after 5A, and it will be operated at 42 East, and it's 1 tons bigger than the 5A, approximately 4.5 tons. And it's more powerful, as I said, it's around 15 kilowatts. And it has more maneuver life than the rest of the satellites we have. And the main mission 5A has is the Ka band. It's an HDS satellite. Unfortunately, maybe some of you are aware of the latest incidents in Turkey. We had a disaster last month, and unfortunately we had to use this satellite in that event for emergency communications. And the good side of this project was we used this satellite with very efficient way. It helped us a lot, and I was happy to give some service over this satellite in the region. It has achieved its goal, actually. And it made me realize how important job we are doing with this satellite business again. And the Turksat 6A is a very important project for Turkey and for myself. It's the first domestic communication satellites of Turkey. The project has kicked off in December 2014. It was a dream for us since maybe 20 years in Turkey to build our own communication satellite. And it has started in December 2014. We don't have a major contractor or one manufacturer in Turkey at the moment, but it's being developed. But it's a how can I put it in words? The project is run by four main participants, actually. The system engineers are TÜBİTAK Space. Thermal and structural subsystem is under TAI responsibility. We have Aselsan, who is responsible of payload subsystems. And the last one is the CTEC, who is responsible for TMTC. These four companies are leading companies in Turkey in space industry. So we are trying to complete the project with these four companies with success. So far, we are doing a good job. The manufacturing has been finished, and the integration has been finished, and we completed last month the thermal vacuum tests of the satellite. The satellite is being prepared for the mechanical tests at the moment. And at the beginning of 2024, I hope, we will see it's being launched from Cape Canaveral by SpaceX again. As I said, this 6A program is very important on our side, since it's the first communication satellite of Turkey, which is developed in Turkey. We have some goals with the satellite. The first goal we have is reducing the foreign source dependence, because we spend a lot of money on procuring satellites, and we are trying to improve our businesses. So as you can imagine, manufacturing your own product gives you some flexibility in that manner. In-house design and manufacturing is one of the key goal we are trying to achieve. With this achievement, we will have a qualified workforce in Turkey and the infrastructure, which we built an assembly, integration, and test center in Turkey, Ankara, in the capital city. With this project, we are getting a lot of assistance and support from the academy, universities, and we have a lot of industrial collaborations with the space ecosystem in Turkey. Also, we are trying to achieve a commercial business here with the first satellite program in Turkey. We would like to enter the international spacecraft market with this platform, and we are developing a lot of equipments and subsystems inside the spacecraft. It was a bit challenging for us because it's a platform from scratch. A lot of equipments we are trying to build in Turkey, and we are trying to be competitive in this industry. It's so when you consider all of these topics, it's a bit challenging for us, but we are nearly there, I hope. Basically, the 6A project is not as big as the previous ones, so it will be operated at 42 East again. Launch mass is around 4 tons. Payload power is around 8 kilowatts. We would like to operate the satellites around 15 years at least, and it will have a Ku-band payload. In the coverage, our classical coverages are included in the satellites, Turkey and the nearby regions. And also it's the first time we cover the Asia, Far Asia for us, the India and the next countries. We started the project in a safe way, actually. We would like this platform to be qualified in every way. So the model philosophy of the 6A had 3 or 4 models. So the first one was the structural and thermal model, which is completed successfully many time ago. And the electrical model, engineering model, and the last one is the flight model. We completed all 3 models last year, and the flight model is, as I said, the integration is completed a while ago, and we are testing the satellite right now. What we aimed with these projects, actually we have all the outcomes we aimed by these projects. The new frequency bands, as I said, especially in 5A, the new Ku frequency band is the first time, I guess we are the 3rd country used that frequency band on satellite. So some of you are aware of the ITU frequency regulations and rights. So using a new frequency band and having the right to use in the future, it's an advantage for us. And also we have current frequency rights. It helps a lot to protect them. And with 5A, we are extending our service areas. With 5B, actually, as I said, it's the biggest satellite in our fleet. It provides over 55 gigabit per second HDS capacity. And the basic services we try to give on the satellite was the air traffic and maritime communications. And the satellite is important in another way for us. There's some problem with the picture, I guess. Yes, it's here. We have two equipments on the satellite. One of them is LNA and the other one is receiver. It's the first time we use our own equipments on a communication satellite, geo communication satellite in Turkey. So thanks to Airbus and the team which has developed these equipments, we are using those equipments in orbit at the moment, and they are all functioning well. And from the beginning of Turksat 6A, we participate all the projects with a training team and also with an expert team. So thanks to these programs, we are able to develop our own satellite programs in Turkey. So again, in Turksat 5A and 5B project, we also 12 engineers participated in these training programs, and they are working on Turksat 6A at the moment, and it's a great achievement for us as well. With Turksat 6A, we will have a national communication satellite platform in Turkey. And as I mentioned in the previous slides, it will have a lot of domestic products and technologies inside. And thanks to these project, we will have integration and test center in Turkey, and we will have human resources for the next projects. In this program, there are 4 consortium members in the project, which have different responsibilities and roles. So TÜBİTAK is an R&D institution, especially. So they are responsible of the system and flight software, etc. And they are developing a lot of equipments in the satellites, starting from spacecraft controller, reaction wheels, interface units, star tracker, power subsystems, and electrical propulsion subsystems, which is experimental, by the way. Interface units, as I said, almost all of the interface units are being developed by TÜBİTAK. Aselsan is responsible of the payload subsystem, who has experience on developing payload equipments before. So, but manufacturing a space antenna is the first time for them. So they did a good job. They have manufactured a top floor antenna for Turksat 6A, also receiver and some passive equipments, also payload interface units, and they are all functioning well at the moment. And the other topic was the telemetry and command subsystem. Another company, CTEC, is responsible of that. They developed command receivers, telemetry transmitters, antennas, and some minor passive units. And the last one is TAI, who is the largest one of the largest defense company in Turkey. They are also in aircraft business. They are manufacturing helicopters, airplanes, etc., like Airbus. And they are doing very well in structure on the satellite. So integration and test center is also located in their facility. They are also manufacturing some panels of the satellite, also the harness. They performed a good job on that. And I would like to give some insights about our projections for the future. Many of you might be aware of what's going on in the industry at the moment. We hear a lot of new topics for a while. One of them is the throughput of the satellites. We are all trying to improve our throughputs on the geocommunication satellites. So a while ago, we were hearing high throughput satellites, but nowadays we started hearing very high throughput satellites and UHTS as well, ultra high throughput satellites. Flexibility is becoming more and more important topic in our industry. And the low latency is another topic we are discussing for a while. When we consider these concepts in our satellites, it comes to the efficiency. To achieve the efficiency of manufacturing or designing a satellites, you need to consider size, weight, and power, and the cost. When we design a mission or decide to buy a satellite, we have to optimize all these factors, and it will give us the most efficient solution. So sometimes you might want to design a big payload, but when it comes to the efficiency, it will not be the only option you have, and you have to consider other possibilities. So also we see new platform types of communication satellites for a while, like small GEOs or non-GSO operators. In the industry, especially for the small GEO platforms, in the previous slides, I told you 5A and 5B have more than 30 years of maneuver lifetime, which is very long time, as you can imagine. And it's not easy job to project a business for 30 years. So when you consider these challenges, small GEO satellites give you a bit more flexibility to design your missions. They have smaller sizes and less lifetimes, but cost efficient and cheaper, of course. So depending on your strategy, you can choose either a larger satellite, which can operate more than 30 years, but also you can choose a smaller one. And depending on your business model, you can replace the satellite in each 10 years or less than 10 years. So it's fully depend on your business model and the fleet design. Also, in the meantime, non-GSO operators are become one of the key player in the market. So at first look, they might seem competitors to us in geocommunication satellites. But I believe when it comes to flexibility, reliability, and availability of geocommunication satellites, we have some advantage on NGSOs. But in terms of low latency, of course, they provide much lower latency than a geocommunication satellite can give. So when we consider all these capabilities of NGSOs and GSOs, I believe there could be hybrid solutions for the industry and for the market. So we should seek for collaborations with this kind of operators as geocommunication satellite operators, which we see some examples in the industry lately. As a satellite communication satellite operator, when we try to buy a satellite or look at the industry, we see some trends and topics are under discussion. I mentioned some of them in the previous slides. One of them is small satellite. Advanced payload systems like flexible repeater systems and also antennas. Satellite IoT, Internet of Things are another hot topic for us. In the manufacturing of satellite, propulsion systems are becoming very crucial nowadays. VHTS and the UHTS is the key concepts, and in-orbit services, advanced ground systems, ground side is also developing based on the developments on the satellite. We are seeing new launch services, and the companies, artificial intelligence is becoming more and more important in the space industry, and additive layer manufacturing is another key topic for us. I found an interesting chart in one of the published, which shows the trends and the percentage of the startup and emerging companies they analyzed. And as you can see, small satellite and satellite IoT is the main driver from 2021. And all these developments are being followed by the operators as well. We are trying to organize and plan our next generation satellites based on these improvements and trends. So in our next generation satellites, we will consider all these topics, and we will try to improve our fleet based on these new technologies, I hope.